Hello, my name is Chris Brinton. I'm a second-year PhD student in the Edge Lab here at Princeton. Over the next few minutes, I'd like to talk to you about a research project going on in our lab, an intelligent satellite overlay for terrestrial CDNs. First, I'd like to give some of the motivation behind this project. As you may know, in recent years, data demands have been growing quite rapidly. In fact, they're growing exponentially and in a wide variety of networks. Some statistics on this. In cellular data networks, traffic is expected to grow 16 times between 2012 and 2017. In video-on-demand networks, the traffic is expected to triple between 2011 and 2016. These demands are increasingly being dominated by video traffic. So what are the implications of such increases in demand? Well, naturally, we have increasing network congestion. Take the example depicted here of a cellular network. As users, we make requests directly to cell towers, which form the radio access network. The demand from these radio access networks get aggregated in what's called the mobile backhaul, which forms the intermediate links between the ISP's core and the cell towers. As our demands as users increase, we have increasing strain on this backhaul, which becomes a bottleneck. The natural question that arises is how can we alleviate the bottlenecks that are present in a wide range of CDNs? Our solution to this issue combines two main notions. First, multicasting. We want to be able to serve bandwidth-intensive requests for the same content simultaneously. Multicasting makes sense here because traffic demands in CDNs tend to follow what's called a heavy-tailed distribution. What that means is that a large fraction of the requests occur for a relatively small fraction of the files. Speaking in terms of probabilities, the majority of the files lie along what's called the heavy tail, meaning that they have a small probability of being selected. The second is the notion of caching. We want to store popular content one hop from the end users. The heavy tail distribution again comes into play here, because if we can learn those probability distributions quickly, then we can determine how to best make use of our available storage capacity by storing those that have the highest probability of being requested. The multicast source that we choose is satellite. Why do we choose satellite? Well, it has three main advantages. First is that it has a homogeneous coverage area. It can cover a wide range of geographically distributed users at the same time. Second is that it allows delay-insensitive traffic to be offloaded, for instance, if the terrestrial network is congested. And third is that it can provide backup bandwidth. But satellite bandwidth is pretty expensive, so we have to be careful. This figure depicts our overlay network from a high level. The end users make requests directly to the local proxy server. If the proxy server has that file in its cache, then it will serve it directly back to the end user. If not, then it will forward the request to the content delivery network. Inside the CDN, a decision will be made as to whether that file should be served terrestrially or whether it should be uplinked to the satellite. If it's to be served via satellite, the central station will send it up, and the satellite will add it to its queue. Once enough requests for the same file have been aggregated, the satellite will broadcast those files down to all the proxy servers within its coverage area. The proxy servers will then make two decisions. First is whether or not they want to store that file, and second is whether or not they have any end users that they need to stream the file to. Research goals in this project can be summarized in 5 main statements. First is a broad, innovative thinking about satellite's position in networking. Where is it now, and where is it going in the future? Second is to quantify bandwidth storage trade-off for satellite terrestrial, multicast, unicast, and other dichotomies that we've painted throughout this presentation. For instance, we've seen that a satellite-based multicast solution has many advantages in terms of scalability when compared to a terrestrial-based unicast solution. Third is to develop efficient caching algorithms to factor in temporal and geographical shifts in popularity so that each cache can make its own decisions. Fourth is to incentivize collaborations with CDN operators to obtain realistic data traces for our analysis that can greatly strengthen our claims. And fifth is to define different tiers of service provision, such as on-demand via unicast and delay-tolerant via multicast, which can be priced accordingly. Thank you very much for listening. If you have any questions, please feel free to email me. My email address is cbrinton@princeton.edu.